Here is a neurotransmitter lesson that I want to go through with you really quickly. I don't know what happened with the video on the last one. That was from last year, so we're going to record a whole new one right now. Really quickly, before we get to the lab tomorrow on neurotransmitters, I want to go through a few things with you today. How neurotransmitters influence us. Now, remember, the neurotransmitters are the really fast chemicals that are happening throughout our entire body, but we're probably mostly focusing on the brain. I'm going to go through the names of these. Keep in mind, we're still finding some, probably over 100 neurotransmitters. These are the 7 that the College Board expects you to know. They expect you not only to know them, but really know their functioning. So I'm going to just pronounce these because maybe they're unfamiliar to you. And then we're going to go through them really briefly. Acetylcholine, if I refer to it as ACH, that is known as acetylcholine. Dopamine, you've probably heard of. Serotonin, I'm sure you've heard of. Norepinephrine. Now, if I call it norepinephrine or epinephrine, it's pretty much the same kind of thing. GABA, it's a long acronym. I think it's on the next slide. Glutamate and endorphins. So those are the 7 that you really need to know. This graphic is a pretty good graphic. Acetylcholine, the function enables muscle action, learning, memory. I'd say the 2 biggest functions that you're going to want to write down if you're taking notes are muscle action and memory. And we know that if there's a breakdown of acetylcholine or not enough produced, it is linked to Alzheimer's. And if you know anything about Alzheimer's, it is a terribly degenerative disease. There's not a cure for it right now. There's Alzheimer's walks because it's when the neurons deteriorate, and first it's attacking the brain, and then eventually it really kind of attacks the whole body, and it's a terrible disease. Dopamine influences movement, learning, attention, emotion. When we talk about attention, we see that people who have ADHD actually have a lack of dopamine. An oversupply, so too much dopamine, is linked to schizophrenia. We will talk a lot about schizophrenia as we go on. The one thing I want you to know is schizophrenia is different than other mental illnesses, almost all other mental illnesses. Too much of it is very highly linked to too much dopamine is linked to schizophrenia. And undersupply, we know, is a result of Parkinson's disease is a result of that. Serotonin, norepinephrine, GABA, and glutamate. If you'd like to take some notes on these and just jot some of these down, that's great, because it might help you tomorrow when you go through the slides or go through the lab together. So how drugs and chemicals alter neurotransmissions. What I should mention before is, depending on the pathway of the neurotransmissions that they take in your brain, depends on how they kind of act or behave. So if neurotransmitters are behaving in the back, what we call the old brain or the brain stem, it affects things like breathing and heartbeat, things that you really don't ever think about or have to control. If it's happening in what we call the midbrain up here, it's like memory and learning. If it's something in what we know as a cortex, which we'll talk about, the cortex or the frontal lobe, it's more perception and like judgments, how you make long-term decisions. So know that different neurotransmitters behave in different ways in the brain because they have a function. So our body produces these natural substances similar to drugs. So now we remember that neurotransmitters are these chemicals, right? Well, our body should produce everything that we need, but sometimes it doesn't. Or sometimes we go down a really dangerous path of finding illicit or alternative drugs to give us the sensation or the feeling that either a neurotransmitter can't do or doesn't do enough of. So when we talk about these drugs or even neurotransmitters, we're talking about how they either increase or block. Now remember this, remember the key, right? An agonist is what we are going to refer to as binding, opening. So an agonist, remember like the dendrites and the terminal buttons have to be almost like right on, buddying up together perfectly. An agonist is going to like accept that. And it's going to bind and stimulate and be like, hey, I'll take that neurotransmitter. But an antagonist is going to block it. It's going to stop that neurotransmitter from being absorbed. Then we know like reuptake happens. So just keep those ideas here in mind for a second. So here's like a good graphic of an agonist versus an antagonist. So you see that receptor site on the receiving neuron. Remember, so you can imagine our human neuron chain, right? The receptor site on the receiving neuron. The neurotransmitter opens the receptor site. It's like, hey, I'm ready. An agonist mimics or like copies the neurotransmitter opening the receptor site. And if we look at this, like this is what a drug would do. An antagonist blocks neurotransmitters from opening the receptor site. So here you see this one is like opening and this one's like stopping. So it's going to like make a little like stop right there, a stop gap. Remember in the synaptic cleft. And agonist is going to be like, hey, yeah, I'm ready to take it. So these are, and it will, and that's how it either fires or it doesn't. Okay, so some of them block, that's an antagonist. Some of them open, that's an agonist. I know I'm going through this really quickly. That's it. Oh my goodness, that's it. That's literally all you need to know. So tomorrow, basically this is the slide that you'll have to kind of keep in mind as you go through that Skittles lab. Okay, see you tomorrow. Talk to you then.